Hi friends, now we will discuss about the gravity dam. Gravity dam is a very important topic for university examination and the competitive exams. So gravity dam. So first of all, what is gravity dam? So gravity dam is a dam. Gravity dam is a dam. This is dam. So water stored in the upstream side, and this is downstream side. So gravity dam is the dam which resist all the external forces only by its self-weight. So this is the definition of gravity dam. It resists all the forces only by its self-weight. So the self-weight means under the action of gravity, the concrete material of dam. So in gravity dam, there are two types of failures are available. There are two criteria. One is overturning. Another one is sliding. So overturning, sliding. So what is overturning? This dam will try to overturn, rotate. But what is sliding? Try to move on the horizontal direction. So the overturning with respect to moment. So the sliding with respect to force. So the factor of safety against overturning is the resisting moment to the overturning moment. Resisting moment to the overturning moment should be greater than 1.5. Should be greater than 1.5. Factor of safety against sliding. So sliding with respect to force. So the PV to the PH should be greater than 1. Should be greater than 1. So in sliding, we have to consider the coefficient of friction. Mu is denoted as coefficient of friction. Coefficient of friction. So the factor of safety against the overturning is resisting moment to the overturning moment, that is greater than 1.5. The factor of safety against sliding is PV, resisting force to the overturning, to the sliding force. Resisting force PV to the sliding force PH. Sliding force PH. So the resisting force to the vertical force to the horizontal force into the coefficient of friction. So that is the factor of safety against sliding. And another one term in the sliding is sliding factor. Sliding factor, that is also denoted as tan theta is equal to PH divided by BV. PV, horizontal force to the vertical force. So these are the main criteria. There are two types of failure available in dam. One is overturning and sliding. So these are the factor of safety against the sliding and factor of safety against the overturning. Then in gravity dam, the tension is not permitted at any point of the dam. So the tensile force is not permitted at any point of the dam. So tension is not permitted. is not permitted. That is the important objective question. The tension is not permitted at gravity dam. So for no tension criteria, eccentricity should be less than B by 6. What is B? What is E? This is the dam. This is our horizontal force. This is vertical force. PV, PH, PV, PH. That is the resultant force, PR. So PR is equal to root of PH square plus PV square. What is eccentricity? Eccentricity is, this is eccentricity. That means B by 2. This is B, breadth of the dam. The B by 2, the distance between the half width and the resultant force is known as eccentricity. So the eccentricity should be less than 1 by 6 of breadth of the dam. That is a very, very important condition for no tension. And another one condition for minimum base width. Minimum base width provided for no tension. This is one condition. This is the next one. So the minimum base width, B is equal to H divided by root of G minus C. H is the height of the water. This is H, height of water stored before the dam. So H, height of water, and G is the specific gravity, C is the coefficient of uplift pressure. So for no sliding condition, the provision of base width. For no sliding condition, the provision of base width is B is equal to H divided by G minus C. In sliding, we will consider the coefficient of friction. So B is equal to H divided by mu G minus C. That is the important one. So there is no tension permitted any point of the dam. That is very, very important note. And E, eccentricity and the base width. Then we move to the forces acting on dam. That is very, very important. The forces acting on dam. Forces acting on dam. Very, very important 16 mark question in analysis examination. So, what are the forces acting on gravity dam? First of all, we know what are the forces acting on gravity dam. That is the water level. This is the top width A. This is the base width B. This is height H. So what are the forces acting? Self weight of the dam W, upward soil pressure, and also uplift water pressure. This is important one. Uplift water pressure, and also we have considered uplift soil pressure. The uplift water pressure, why we consider? Because the water stored before the dam, it percolates it, and it affects below the dam. So we have considered the uplift pressure of water also. So then the water force, then the water pressure, then wave force. You have to consider wave force and earthquake force. So the forces acting on dam, self weight, upward soil pressure, uplift water pressure, then the horizontal water pressure, that means pH, horizontal water pressure, wave pressure, earthquake force, and the last one is silt pressure. The silt pressure is acting downside due to the deposit of sand, silt. So this silt pressure act at the downside of the dam. So we will discuss briefly. Self weight. So self weight. How to calculate the self weight? The self weight is considered unit weight into volume. The unit weight of the dam material. Dam material means the concrete and the volume of the dam. So we have to take the self weight. That is acting downward. So the next one is upward soil pressure. P is equal to summation of W divided by P, 1 plus or minus 6E divided by the important pressure on the dam. So P max, P min, maximum pressure and minimum pressure. The maximum pressure acting the upstream side of the dam. The minimum pressure acting the downward side of the dam. So P max we have to take plus for P minimum, the minimum pressure 1 minus, take minus the distribution diagram for the dam is this is P max, this is P min. This is P max, this is P min. So the third one is uplift water pressure. That is act like C mu H. C is the uplift pressure coefficient, mu is the unit weight, H is the height of water. So C mu H. In downstream side, the uplift pressure is 0. The uplift water pressure is 0. In upstream side, that is maximum. That is maximum uplift water pressure. So then Then we will discuss about wave pressure. Wave pressure. PW 2.4 UW HW square. So what is HW? HW is height of wave. How do we calculate the HW? HW is 0.032 root of VF. 0.032 root of VF. V is the velocity of wind. F is the fetch of reservoir. Fetch of reservoir. What is mean with fetch? Means the dam the length of the reservoir, the length of the water storage area. Length of the water storage area is known as fetch. Fetch of the reservoir. So the velocity of wind. So the wave pressure act like this. This is height of wave, HW, height of wave. In above water level and below water level, the height of wave is act like 1/3 of HW, 2/3 of HW, 2/3 of HW. Charts the above the water level 1/3 of HW height of wave, below the water level 2/3 of HW. So this is applicable for F less than 32 km. F less than 32 km. If F greater than 32 km, height of wave 0.032 root of Vf plus 0.763 minus 0.271 F power 3/4. This is wave pressure. The resultant wave pressure is act. Resultant wave pressure act 3/8 height of wave. 3/8 height of wave. The resultant pressure act from 3/8 of height of wave. So this is wave pressure. This is wave pressure. Another one is earthquake force. Earthquake force. Earthquake force. Earthquake force. So the P is equal to 0.555 alpha UW into H. So the alpha is the acceleration. Alpha is the acceleration. During earthquake, the water will accelerate. So the alpha is taken as the acceleration. There are two acceleration available during earthquake. So the alpha H, alpha V. Horizontal acceleration and vertical acceleration. Horizontal acceleration and vertical acceleration. Okay, are you clear? Horizontal and vertical. So in horizontal acceleration, the value is up to 0.1 g to 0.2 g. G is acceleration due to gravity, that is 9.81. So alpha H value is 0.1 g to 0.2 g. The alpha V, the vertical acceleration 0.75 alpha H. So this is the earthquake force. We have taken anytime alpha H to calculate the earthquake force, because these two values, in these two values, the alpha H horizontal acceleration will be more at any time. So we have to consider the alpha H in this equation to calculate the earthquake force. And another one is silt pressure. This is a very minor pressure acting on the dam. It's a very minor pressure acting on the dam. The major pressure are self weight and the water force. Okay, the two forces are main forces. Self weight and the upward soil pressure and the water force. These three categories are very important. These are major forces acting on the dam. So now we are discuss about silt pressure. Silt pressure, PS, of Ka mu sub Hs. K is the earth pressure coefficient. Earth pressure coefficient, submerged rate of silt soil. So silt, H is height of silt. Silt is deposit like this. So silt force acting on the. So these are the forces acting on the dam.